What are the physical quantities in the expression for the flow resistance? And this is, again, for Poisson flow, even though it doesn't say that there. And there's the expression R is equal to 8 eta L over pi R to the fourth. I think the thing that's the most tricky about Poisson flow is, well, I mean, if you had to memorize something, right, if I had to do this without being able to look up the formula, I think remembering this formula could be tricky. And fortunately, often these days, we don't have to do that anymore because we can look up formulas pretty easily now. But the other part is remembering what all the different parts of it mean. So that's why I have this question here, so we can kind of go over that. And my whiteboard's pretty cluttered here. But maybe I can just add to what I've already got here and say, so we have this symbol eta, which is kind of a Greek letter, and I didn't write it very well there. But that's equal to the viscosity. So it's very important to recognize that viscosity is in there, since this is a model of viscous flow through a pipe. And then there is that, it's meant to be an L, but the program I use for the slide makes L's and I's pretty much look identical, at least capital I's look identical. But that L is really the length of the pipe. So I'm going to write that in here. Length of pipe, I think we'll do. Okay. And then we have R. And notice that it's R to the fourth. I've often found that interesting. It's really a pretty large power there, indicating a large amount of dependence on really actually the radius of the pipe, but maybe more precisely I could say that that is the inner radius of the pipe. So that's those three things I've added in here for that formula really comprise an answer to this question. We can go and look at this here. It says, indeed, eta is the viscosity of the fluid, L is the length of the pipe, and R is the pipe's inside radius.